I guess for now, just comment in the chat bar and we'll pay attention and see when you comment. Sorry, dude. All right, so did anyone have any questions with the first homework assignment? Or with any of the assignments for the last week?
You're talking about last week's assignments or just section 1 from this week? Or section 1,
2, or any other general questions about the course?
I'm good other than finding sine and cosine of like when it's written with like pi as an integer.
Okay.
That makes sense.
Like when it's in radians?
Yes, that.
Well, do you know how to change it from radians to degrees?
Yep, that's fine. It's just once we move over to the sine or cosine, or maybe I don't understand what that means.
Okay. Did you read the storyline assignment that he gave us?
Is that?
It's a really, really long article with a whole bunch of assignments within it. At the very end.
Oh no, I did assignments that were. The assignments I did were in the My Math lab.
Okay.
So then maybe I missed something.
I'm still trying to figure out how to find what assignments are due in my math lab. So I've been talking to Mr. Jordan about that.
I think as far as my math lab goes, when you go to content, I'm looking on it right now.
Right.
In the right hand, wait, no, sorry. Not content.
No, I think you're right. It's under like when you go to the content, the left hand, there'll be a link for My Math lab.
Yeah.
Right.
So
And
then you click on assignments.
Okay.
Right.
So you did the My Math Lab. Did you do the readings that are actually in the? So if you go to week 2, under date number 1, it's got the preparation resources. And each of those tabs has different articles and assignments for us to do. But those ones aren't graded. Those are just so that you understand. Because that's where we print out the blank unit circle.
See, and I got the vocabulary and I got the unit circle. And then I've got the other thing that I pulled up was Math is Fun, and it pulled up like a mathisfun.com unit circle.
Yeah, that's fun. I don't think I used that.
It's a creative title. Math is fun. So were you saying you didn't understand how to find like sine and cosine? So on the unit circle, do you know how to find it on the unit circle when you're looking at it?
I have like understanding of it. Like, so on that Math is Fun link, I swear I pulled it from our page. It shows like it has a unit circle and it's like, you know, you can test where, so like if like sine is 0, cosine is 1, tangent 0, like it shows every one of those degrees on, but not how to convert it to like a decimal. Does that make sense?
Yeah.
Okay.
I think so.
So you, hold on. Let me just pull it up. The math is fun.
I can put here's the link. I'll just put it in the chat box.
Oh. That's convenient.
Okay.
So were you able to fill out the unit circle? Go through all of the...
Well, that was actually one of like the homework assignments in my math lab. So I filled it out what I did in my math lab. Like one of the homework questions in my math lab was filling out radian and degrees of the circle. That's how I filled out the unit circle.
Okay. So then when you looked at the homework that we're supposed to do as a group, did you understand how to find sine of the quantities and radians? Or is that what you're talking about? You don't quite get it.
Number 2 on our, what we're supposed to discuss as a group, right?
Yeah, so
Number 2.
it comes up, it's purple, mine's gray, but it looks like that. And it's the group homework, so it says all the problems at the bottom. And it asks you to find cosine and sine for different radians.
Yeah, that's what I'm talking about, where it says extension problems, find sine of 3. That's what I'm talking about.
Okay. If you filled out the unit circle, then finding sine and cosine is pretty easy. You know what? I keep forgetting that my camera, for some reason, flips all the images backwards. So when I try to show people on my webcam, it doesn't work. But as we go through the assignment, and stop me if I'm not making any sense. Imagine that this is 1/4 of the unit circle.
Okay.
When we do the assignment, we find 30, 45, and 60 degrees. Sine is the y value of each triangle. So if you're looking at a triangle within the circle, sine is really just saying how tall the triangle is.
Okay.
Right? And then x is cosine, which tells you how wide the triangle is. So in order to find it, all we have to do is plug in the angle. And when you do the assignment, on the unit circle, you already converted all the degrees into radians. And so
Yeah.
all you have to do on a calculator is type in sine of whatever radian it is, whether it's pi over 6, pi over 4. Does that make any sense?
Yep.
More or less?
My calculator's my phone, so.
Okay. So having said that, let's see, make sure everyone has filled out the unit circle correctly. Having said that, can you plug in sine of 4 pi over 3? And let's make sure we all have the same value. So what do you get, Adriana, when you have it?
That can't be right. 4.18.
I wonder what... I want to see what my phone does. I have a graphing calculator, so I can kind of cheat.
Well, you're using a calculator, just plugging it in with sine, right? And it might be on degrees. You might want to check to make sure it's check radians.
See, my phone doesn't even come out with the right answer.
I'm not sure which calculator you're using, but with most scientific calculators at the top, there's going to be a button that says DRG. And you click on that and you just move it over to radians. I'm not sure what it is for graphing calculators because I'm not using that right now. But there should just be a button.
So you're saying that instead of showing like decimals like that,
Right. It'll show
then
radians.
it'll show like the pi sign.
No, it doesn't show the pi sign. It'll still just have a decimal, but the decimal that you were getting was off. It should be like negative 0.86 something.
Okay, then I might have to buy a new calculator. Because all I have is what's on my phone, and like you rotate it sideways and it's a scientific calculator, but like there's no button to change, I guess, the format or anything.
Actually, if you're using the one on your phone, there's a button at the bottom left corner. When you turn on the side, it says RAD, and you press that to make it radians.
Okay.
So maybe try putting 4 pi over 3 into that.
I get negative 0.866.
Yep. Which I'm not sure how you would convert that exactly, but it's negative square root of 3 over 2. So that's what I got.
Right. That's what I have as well. Does everyone have their unit circles in front of them? It might be helpful if we go through all the sine and cosine for each angle.
I have mine.
You have yours?
I do.
Mm-hmm.
Pablo says that we've disappeared. Okay, so starting at 0 degrees, which is the horizontal line on the right side, I have 0 degrees, 0 pi, the x value is 1, and the y value is 0. Does that sound right?
Mm-hmm.
Yeah.
Okay. And then at 30 degrees, it is also pi over 6. The x value is square root of 3 over 2. And the y value, the x value is square root of 3 over 2. And the y value is 1/2. And then for 45 degrees, I have pi over 4. The x value is square root of 2 over 2. And the y value is square root of 2 over 2. Since it's a 45-degree angle, x and y are equivalent. 60-degree angle, x and y are reversed of the 30-degree. So x is 1/2 and y is square root of 3 over 2. And the radian equivalent is pi over 3. So far, so good?
Yep.
Okay.
Yeah.
And then at 90 degrees, it's pi over 2. And then the x value is 0 and the y value is 1. And if you have that, all you have to do is mirror it around the rest of the circle. So if you go to quadrant 2, the x value is just negative and the y value is positive for every single angle.
Makes sense.
Make sense?
Mm-hmm.
And then when you go down
Yep.
to quadrant, they call it quadrant 3, it's just where everything's negative. The x and y values stay the same, they're just all negative. And then again in the fourth quadrant, x value is positive and y value is negative. And for the quiz and like all the assignments, if the unit circle's filled out, it's really easy to do them all. Because all they're asking is for the values off of the unit circle.
Okay.
So like when we do the homework and they say, what's the sine of 7 pi? If you have your unit circle and you know that each 360-degree circle is 2 pi, then you just go around the circle 3 times and a half, or 7 pi, and you know that they're asking for sine, so you know that sine is 0, because sine is also the y value. Make sense? Yeah, no?
Yep.
Yeah.
Okay.
Are we?
I don't ever feel like I'm very
allowed
good at
the
explaining
unit
things.
circle? Sorry, are we allowed to use the unit circle on the quiz? You guys know?
No, I have no idea. Take a look.
I feel like I read that it was an open book, but I'm not positive.
Okay.
You know, for a course this fast, I can't imagine they would ask us to do it without the open book.
True.
In fact, I seem to recall reading that we could.
I felt like I read that we could do it.
I felt that way, but I felt like I might have been getting it mixed up with a different
GHOA.
class or something. I don't know.
You're allowed to use your books, notes, and calculator, but you're not allowed to use any outside resources, mostly people.
Okay.
So, yeah. So yeah, we can use the unit circle on all of our assignments and homework and quizzes. And other such wonderful things.
Cool.
Okay, so should we go through the homework and just answer the questions?
Sure.
Is everyone caught up?
Where is that at? Is that under instructions for GHOA?
Excellent, exit out of it. It is in, it's in week 2. Give me a second. All right, week 2,
It is
due
under
date
the
number 1.
instructions.
It is lesson, oh no,
1 and 2.
where is it? Yeah, it's in the group instructions.
Okay.
So lesson 1 and 2 instructions.
Cool.
So we found that sine of 4 pi over 3 is negative square root of 3 over 2, which when you look at your unit circle, 4 pi over 3 is in quadrant number 3. It's the 240-degree angle. And the y value is right there. So sine of 7 pi was 0 because it's equivalent to the 180-degree angle. And then Elise, do you know sine of 7 pi over 2? The third question.
Yeah. I mean, I can find it. Hold on. That was a sine?
Yeah,
Right.
so sine of 7 pi over 2.
So that would be -1, right?
Yes. It would be -1. And then, sorry, Paulo's having trouble still seeing us. Okay, so Adriana, do you know cosine of -9 pi?
That's just the x value.
Yes. The x value of -9 pi. So if you just go around the circle so many times, that equates to one of the angles on the unit circle. I'm going to try something real fast. Okay, can you see that? It's showing it on my screen.
Yeah.
Let me zoom in. Okay, so there's a completed unit circle. Oh, look, you can see my mouse too. Okay, this changes things. So to get negative 9 pi or any other value, you literally would just count pi. You would go 1, 2, 3, 4, 5, so many times around. And then you would wind up at whichever value it winds up being. So knowing that, where is negative 9 pi?
So when you're doing negative, are you starting
You count clockwise.
clockwise? Starting
Currently
at 1, 0? Is
at 0 degrees and go backwards.
so it ends up being negative 1.
It does wind up being negative 1. Yes. And then cosine of pi over 3 is 1/2, as we can see right here. Now you understand how we get these values, right?
Now I have a better I understand it better, but
There's a whole, I'm not entirely sure how I understand and how they figured it out. But because everyone knows Pythagorean's theorem, a squared plus b squared equals c squared.
right.
And because someone a lot smarter than me figured out that you could decide that every single triangle with a certain angle has the exact same proportion, they realized that if you just make the hypotenuse number equal to 1, then let's see, we just found out pi over 3, so we're looking for the x value of pi over 3. So what they realize is, hey, if you take a 1 radius triangle and you find the proportion to in this case, the adjacent line, which also winds up being the x value, that x value will always be 1/2. And the y value will always be the square root of 3 over 2. Part of the homework was to prove that. Honestly, I don't think I did it right. But that's what winds up happening. So if you can imagine, you're basically drawing a rectangle at every single angle to prove what the adjacent and opposite values are of
Okay.
each triangle. So then with the unit circle, you just fill it out, and you automatically have the x and y values for these are called the common angles, 30, 45, and 60-degree angles going all the way around. So that's all it is. There's no magic answer. And
Will you put the links in the chat?
Sure, I can do that.
Thank you.
Yeah. Pablo's still online. I don't know if you can see us. Just ask instead of texting. So cosine of pi over 3 was 1/2. And then in cosine of 7 pi over 4, again, cosine is just the x value. So we see that it's square root of 2 over 2. I think the only other really tricky one on here was 19 pi over 6. I think I cheated. I think I just plugged it in my calculator. But if you were to count, because counting is fun, apparently. Each circle equates to 12/6, like a pizza. Is that right? Yeah, 12/6. So then you would say, okay, well, since it's 12/6 and every half of a circle is 6/6, if I can say that without saying it with a lisp. So you have 12, 18, and then 19/6 is coterminal to 7 pi over 6. So the cosine winds up being negative square root of 3 over 2. Make sense?
Yeah.
Yep.
Then, oh, who had to get off at 6:40?
Me.
Was that you?
Oh, I gotta go get my kid. Yep.
Go get her. That's important. It's a girl, right?
Bye, guys.
Bye.
Thanks for joining us. Okay. Pablo's staring really intently at his screen. I can't tell if he can hear us or not. So, Elise, do you understand the next question? The proving, let's see, what does it say? Proving the identity theorem.
Okay. Okay, sorry, I'm trying to find it. Proving identity. Sorry, where is it?
It is question number 2. It's underneath all the extension problems we just did.
Okay. So the one that says find sine pi over 3 and cosine pi over 3?
Yes.
Like, do I understand how to do that? I'm not sure I understand the question.
Well, I take it based on what everyone has said so far that no one has yet.
Sorry, what was that?
So I take it you haven't seen this assignment yet. So you haven't gone through these questions.
Not in depth. I mean, I looked at it and I figured out some of the answers. Trig, yeah. Sorry.
Husband?
Yeah. Yeah, that's my husband.
Okay.
He just got off work.
Be proud.
Yep, I am proud.
My wife and daughter decided to go up to her mother's house. So they didn't want to listen to me talk about math. She said it made her jealous because she's doing pathways right now.
Hmm?
You said you are for now.
No, I said I am.
For now what?
I didn't say for now. Sorry. Miscommunication. Okay. So
For question 2, you need sine of pi over 3 and cosine of pi over 3. Since we have the lovely unit circle already pulled up, let me go back in here. We know that sine is, my talk emblem is on top of it. Okay, so sine is square root of 3 over 2, and cosine is 1/2. Here's square each of those values. I wonder if there's a way that I can try this. Oh no! My computer just updated Windows 10, so I lost everything.
oh no.
There it is. I don't like Windows 10 at all.
Did you get the sum?
Sorry?
Did you get the sum yet?
Yeah. Well, I've already done this assignment.
Oh,
I did it a couple days ago.
cool.
All right, so,
I just did it and I got 1.
okay. Well, then you did it right, because the answer is 1.
Oh.
Well, I guess I don't have to do this. I could just do it to confuse Pablo. Oh, he left.
No.
All right, so then it asked, what do you think would happen if you do it over with pi over 4 and it's pi over 6?
What do I think would happen?
Yeah. What would be the square and sum of each value?
I'm not sure. Probably 1.
It would be 1. Since we've already decided that a squared plus b squared, oh, Paulo just came back in. A squared plus b squared equals c squared, and we're using a unit circle where the radius is always 1, then it would make sense that, I wonder if I can, oh, I can't draw on there. It would make sense for the y value and the x value of a hypotenuse whose length is 1 to square and sum to equal 1. So no matter which triangle you do, the answer will always be 1. And that's what they're asking for, is that we understand that all this came out of Pythagorean's theorem.
Mm-hmm.
Okay, so question 3 is basically the same question, just asked differently.
Okay.
So let's see. Actually, I'm not even entirely sure that it asked a question. I think it just asked if you watched the PowerPoint. So have you read?
Watch a PowerPoint. I'm not sure if it was the right one, but
Sorry, the first week is confusing.
a little chaotic.
Stop sharing. Okay. So have you read section 5.2 out of the textbook?
I have not read that yet.
Okay. All right, that's wonderful. That's okay. Yeah, the first week, I got a little help. I emailed Brother Jordan. That's his last name, right? Jordan, something like that.
Yeah.
Scott Jordan.
I
I
think so.
emailed him to ask him exactly what it was we needed, because if you went into My Math Lab, it said one thing, but if you went to iLearn, it said something else. And if you clicked on the homework assignments, it said something else.
Mm-hmm.
So I asked what we needed, and I was able to read the chapter. And in the chapter, they ask about, no, I should have just left this paint up. They give us kind of a real world application. Pablo, can you hear us now? I'm still trying to figure out your computer. Pull this up. And I'll go back into screen share. Okay. Actually, just move this all the way up. So in the homework, they say, okay, you guys have learned all these, wonderful, amazing things. Let's apply it to something somewhat useful. And so what they ask is there's like a weight on the end of a spring or a string, and they want to know how well I can do this. Teachers on iLearn make this look really easy. So they want to know where this weight will be given a certain value of time. And they give us an equation, and quite frankly, I have no idea how they got the equation. Let's see if I can do this. Looks like this. So V stands for velocity. The 0 with a slash sign, I did not do that very well. It just stands for theta. Theta is like a generic term for an angle.
Mm-hmm.
So it's just saying, hey, what's the value of an angle? Oh, that's great. Okay. And then they ask for W. Let's see. Go through this. And just write it out as fast as I can here. Do.
Is that int? Or
Sorry?
Is that integer?
No, it's W. Sorry, W.
Oh, okay, no, you're good.
Starting to get really jealous of my chemistry teacher. He does this every day, and he makes it look super easy.
Mine
Okay.
too. Are you taking it from
That-
Collins?
What is that?
I said mine too. Are you taking it from Collins?
No, I'm taking it from Willis.
Willis? Okay.
I'm strictly an online student. I live in Salt Lake City, so
Yeah,
I am nowhere
Collins is
near anywhere you
online.
can get
Collins teaches online too.
this. Yeah, I have Brother Willis, and from what I understand, he's the program director. So he's really good.
Oh, okay.
Okay, so we have this wonderful equation, which makes absolutely no sense to me. But they gave it to us, so I'm not going to complain. And then they said, okay, the W stands for the, if I remember right, it's like the resistance value for the spring and weight. And they said, we're just going to make it 1. That way it's easy for you. And then we'll give you a velocity of 3, this is so bad, 3 centimeters a second. So that's how fast the spring starts to swing. And then on top of that, they said, hey, the spring started at 2 centimeters. That plus sign stands for above equilibrium. Equilibrium is just vertical.
Mhm.
So when you swing something, it'll swing, and then swing, and then it'll just eventually stop.
Right.
So the resistance value is, how much acceleration it has after each swing. You have your acceleration, and then you have your starting point. And then they said, hey, let's, what this is after 2 seconds. Now, they're kind of tricky because if you complete the unit circle, this is the bottom half of the circle, right? So you start somewhere up here, you go down, and this is the drawing that's in the book. Mine's just a really bad version of it. So you start there and you're going down. Well, what that means is you're now traveling backwards on the unit circle.
Mhm.
It's actually negative. So then what we do is we plug x equals -3 over 1, which is -3. Sine of 1 times 2 plus, and cosine, since it's the x value, oh, I'm sorry, this was 2 centimeters above equilibrium. It wasn't 2 centimeters vertical or horizontal. So they're saying 2 centimeters back from whatever equilibrium is. So cosine winds up being 2, or sorry, that didn't make any sense. You multiply cosine by 2, since that's where you start. And then you have that wonderful 1 times 2 again. Are you able to plug that into your calculator?
Yes, 1 second. So I get -3.56 and then a bunch of numbers after that.
Okay,
Is that right?
that is exactly right.
Okay.
-3.56 or -3.6. And then as a follow-up, they ask us to do it again at 3 seconds. Well, fortunately for us, all we have to do is change the time value.
Right.
So can you plug in the equation using just 3 seconds?
Yeah, we switched that out with the 2, right? Or
Yeah.
Okay.
So the 2's that are in the parentheses, not the 2 in front of cosine,
Right.
because it's the same starting point, just a later point in time.
So that gets negative 2.4033, blah, blah, blah. Right? Put it in wrong.
Actually, I'm not sure. I don't remember if the book had the answer or not. I have negative 0.9, but I could be wrong. Go in here. Let's see, it's in my math lab. I don't like the way they've got this course set up. In the other math classes at BYU, my math lab is a completely separate entity.
Yeah.
So you're able to actually go to the web page. You don't have to view it within the iLearn window. It's a lot easier to do it that way. Well, someday. I'll stop sharing so that you don't have to watch my computer load.
Okay.
So when you typed in for 3 seconds, you had negative 3 sine times 3, or negative 3 sine of 3 plus 2 cosine of 3, right?
Right.
And you got what?
Negative 2.403.
Well, that's why. My calculator tries to keep it in radians.
Right.
And so all it does is say, hey, it's sine of 3 and cosine of 3. Give me a second. Wonderful world of Google. Oh, you're right. It's negative 2.4. I was wrong. Okay. Well, very cool.
Cool.
That's all for the homework assignment.
Okay.
Okay. And everyone left, so we don't even know when we're going to meet for the Thursday group meeting.
We'll figure it out. I only have one class tomorrow, and I don't have anything else going on those 2 days. So I have a fairly open schedule. So I'll just keep an eye on the texts.
Good. Okay. I think Adriana and I are the parents in the group. Oh, speaking of which, that's my wife. Okay. Well, we'll figure it out through text. Thank you.
Cool. Thanks. Nice to meet you.
Have a good night.
You too.
Good to meet you.